Today's video is the third video in my series where I install my completely over-the-top Multiroom audio system. In the previous episodes, we talked about my plans, ran through all the hardware we'll be using, and then took an in-depth look at the Biamp Tesira Server I/O DSP that I'm using as the brains of the system. So now in this episode, we'll be taking a look at how I'm going to send audio from all the TVs around the house into the system. And for that, I'll be using Dante, which is a really cool high-end audio over IP system. So first up, let's have a quick recap as to what I'm doing here. I've installed a bunch of ceiling speakers around the house, all wired back to the rack in my garage, where I have the amplifiers and the Tesira. I can then connect various audio source devices into the Tesira and route the audio around the house. That's fine for things like music, where I can just install the audio source device in the rack and plug it directly into the Tesira. However, I want to also be able to send audio from all my TVs around the house into the system so that I can listen to TVs through the ceiling speakers. Of course, one way I could have done that was just to run dedicated audio cables from each TV down to the rack. But the issue with that is analog audio signals are prone to interference, so running them long lengths through a building where the cable might end up close to mains electricity isn't really ideal. So instead of that, I just ran an additional Cat6a drop to each TV, which gives me tons of flexibility. I could use a cheap audio over Cat system such as this to route the digital audio down the regular Cat5 cables. This isn't a network device, it just uses the cable, so you install a transmitter on one end and the receiver at the other, and it sends digital audio down the cable. Alternatively, if I did want to go down the analog route, there are systems that will send a balanced audio signal down a Cat5 cable, and at least with this being balanced, it won't be as prone to interference. However, there's a third option, which is an audio over IP system, and that will send the audio over a regular network. There's a bunch of different options out there, but the two main ones in the Pro AV space are AVB and Dante. Both of these offer the ability to send high quality audio over an Ethernet network with extremely low latency, making it suitable for sending audio from TVs without introducing lip sync issues. With both of these, you can get an audio interface device that has a range of different audio input and output ports, connect them to the network, and route audio between them. So as I mentioned, there are two main standards for this, AVB and Dante, with AVB being an open standard and Dante being a proprietary system developed by a company called Audinate. At first glance, AVB being an open standard seems like it would be the obvious choice. However, while AVB does work over an Ethernet network, it requires your network switches to have explicit support for it. And this isn't something like VLANs that all decent switches will support. AVB support is only really available on special AV switches, or where it is available on a more conventional switch model, it often requires an additional license to use it. On the other hand, Dante can be used over a standard IP-based network. You just plug the devices into a switch, they'll either get an IP address over DHCP if you have a DHCP server available, or they'll just self-assign IP addresses and they should just work. That said, it is still very dependent on a stable, low latency network, so you could probably run into issues with a complex switching topology or heavy congestion, but for a setup like mine where everything Dante related is connected to a single switch, it works absolutely fine. The only other thing to bear in mind with Dante is that while it is an IP-based protocol, it's not designed to be routable, so all of your Dante devices will need to be on the same subnet and layer 2 segment. Then the other thing when it comes down to AVB versus Dante is in terms of the available hardware. There just isn't anywhere near the range of interface device options with AVB as there is with Dante. With Dante, there's absolutely tons of options from XLR interfaces to digital audio and even Bluetooth interfaces. You can even get mixers that support Dante, so you can send audio in and out of a physical mixing desk entirely over the network. On the other hand, when it comes to AVB, there just isn't as many options. There's a bunch of sort of desktop type audio interfaces, but that's really it. You don't get kind of the range of input devices that you get with Dante. So, as I'm sure you can tell after that description, and probably the title of this video, I've gone with Dante for my setup. So now here we have a selection of the Dante interfaces that I'll be using in my setup. Since my main goal is to get audio from the various TVs around the house into the system, I'll predominantly be using these Blustream DA22 OPT devices, which connect to the Dante network and provide a pair of Toslink connections for optical digital audio. So I can just connect the audio output of each TV, the optical output, into one of these, connect to the network over regular Ethernet, and route the audio into the Multiroom system. As you can see, we have a pair of Toslink connectors for the audio, one labelled in and one labelled out. That's because these adapters can both send 2 channels of audio into the Dante network and also receive 2 channels of audio from the Dante network. Although of course in my setup here, I'm only going to be using this as an input device, so I'll be using the input port to send audio from the TV into the Dante network. Then around the other side we have the Ethernet port which connects to the network, and it also supports PoE, so we can power it over PoE, which is what I'll be doing, but if you don't want to do that, you can also connect a 12 volt DC power supply to this terminal here. Now, as for why I particularly went for an optical interface over various other options, it just seemed like the safest bet. It removes a pair of additional analog to digital conversion steps compared to using an analog Dante interface, and whereas a lot of TVs will mute their speakers if you connect something to their headphone output, they don't do that with optical audio. So that means it'll make it much simpler to switch between the multi-room system and the TV speakers just by muting or unmuting the TV's volume. Blustream also do a very similar adapter that uses HDMI ARC, so that could definitely be also a great option, but I didn't end up going for that just because I didn't want to take up every TV's ARC port, just in case I ever wanted to connect a soundbar or something in addition to the multi-room system to one of my TVs. Plus, if I ever did fit a soundbar, I could then use the optical output of these interfaces to send audio from the multi-room system into the soundbar. The only other thing to bear in mind is that both the optical and HDMI ARC adapters are only designed for stereo audio. They aren't going to be suitable if you want to send multi-channel surround sound over them or something like that. The next interface I have is the Blustream DA22 DIG, and this is what I'll be using for my living room TV. Whereas in every other room I'll just be connecting the Dante adapters directly into the TV, in my living room I have a surround setup with a separate AV receiver. However, what's really good with my particular receiver is that it supports downmixing whatever surround sound source is playing to a single stereo RCA output. That means that I can send the audio that's playing in the living room over Dante without losing the surround sound in the living room itself. However, since my only option is those RCA outputs, I needed a Dante interface that supported an analog input. Of course, there's loads of them out there, but I also wanted the ability to send audio from the multi-room system back into my AV receiver. Of course, I could do this over an analog connection, but once again, using a digital connection would eliminate a pair of analog to digital conversion steps. So with those requirements, this device is absolutely perfect. In particular in the back, we see a ton of different connectors. The green connectors are for analog line level audio. This supports balanced connections, but of course it'll be perfectly happy with the unbalanced output of my AVR. I'll just need to make up a couple of cables to go from the Phoenix connectors on the back of this to RCA plugs. Then next to that we have both optical and coax connections for digital audio, and as you can see we have two different rows of these connectors, the top ones being inputs and the bottom ones being outputs. So with this I can plug the downmix stereo RCA outputs of my receiver into the analog inputs on this, and then I can connect the optical audio output of this into one of the optical inputs of my receiver to feed audio from the multi-room system into the receiver. The only thing to bear in mind here is that this does still only support 2 channels in each direction. So all of the outputs will just mirror each other, and then when it comes to the inputs, you'll need to select which input you're using this little switch here. Then we have a pair of other switches. These just adjust the settings for the analog inputs, so whether they're line or microphone level, and whether you want them to output 48 volt phantom power. Then finally, we have a couple of level adjustments for the inputs and outputs, an Ethernet port that once again supports PoE, and another 12 volt DC input. And now finally we have the last interface I've gone for here today, which is the ESI Planet 22C. And I bought this as kind of an auxiliary input-output device sort of thing. If I need to send audio into the system or get audio out of the system anywhere in the house, I can just plug it in, connect it up with the appropriate cables, and it'll work. On the front we have a pair of inputs and a pair of outputs. Each of these uses standard balanced TRS jacks. Then around the back we have our Ethernet port again supporting PoE, a 12 volt DC input that all these devices tend to have, and a couple of switches that adjust the signal levels of both the inputs and the outputs. So this is going to be a sort of ad hoc device I'll just use whenever I need it. I might end up leaving it on my desk and connect it into my studio monitor interface and just kind of use it to get audio out my studio monitors, something like that. And with these being TRS balanced jacks, I can convert them to RCA, 3.5mm, whatever I need really, so that should be quite useful. So with these devices, I can just connect them all to the same network and route audio between them. But how am I going to get that audio out of these and into the multi-room system? Well, if you've seen my previous video, you'll have seen the Biamp Tesira Server IO DSP that I'm using at the heart of the system. And my particular machine contains a Dante card which supports up to 64 input and 64 output channels of audio. So with that connected to the network, all I need to do is route the devices from all the individual Dante devices into Tesira's Dante card and it'll just work. I don't need any sort of physical connection for each TV's audio at Tesira's end, it's just fed straight into Tesira over the network and then it comes out to Tesira direct to my amplifiers. So, I keep saying that you can route audio between these devices, but how? Well, for that, you need a piece of software called Dante Controller. Now at first, the idea of desktop controller software doesn't sound great, but it's actually fine. It's not really a controller in the sense that it would need to be running whenever you're routing audio over Dante or anything like that. It's more of a configurator. You run the software, configure the routing between all your inputs and outputs, and then the devices just remember what they were set up as. You can shut down the devices, close the controller software, power cycle devices, do all that sort of stuff, and they'll continue to work. So for my setup here, once I've configured each device to route its audio to the Tesira, I should never really need to use the controller software again. So to test this out, what I've done is connect a couple of my Dante interfaces to the network down here. The Blustream is plugged into the network and connected and powered over PoE. The ESI is plugged into the network and it's powered over its 12-volt adapter. The only reason for that is just because only one of these ports here is connected to the PoE switch, other ones aren't PoE, so I've done that there. They both do work over PoE absolutely fine. And then in addition to those two devices, I also already have another Dante interface and a Tesira already connected elsewhere in the house. And this PC running the Dante controller is also connected to the same network. It's generally good practice to isolate the Dante devices onto their own VLAN, so that's what I've done here. And I've just temporarily shifted the PC onto the Dante VLAN so the controller can find the devices. Since, as I mentioned earlier, Dante isn't designed to be rootable, so you do need to have the controller on the same network as the devices. And as you can see in the controller software, it's found all my Dante devices automatically. Dante uses multicast DNS to allow devices to find each other on the network, so you don't need to mess around with setting IP addresses or anything like that. You just connect them to the network, they'll either get IP addresses using DHCP or self-assign their addresses, find each other using MDNS, and start working automatically. Then the main section of the Dante controller software is this big grid here where you patch all your inputs and outputs together across all your devices. Along the top here we have the transmitters, and then down the side here we have the receivers. The transmitters are devices that are sending audio into the Dante network, so that applies the input ports on each of the Dante devices. Then the receivers are devices that are receiving audio from the Dante network, so those would represent the output ports on each of my Dante interfaces. So it's a little bit confusing to get your head around since audio going into an input port on a Dante device is being sent out into the Dante network as a transmitter, and then vice versa, where it's audio being sent from being received from the Dante network is then output through the output on a physical device. So kind of flips around there, gets a bit confusing, but once you get your head around it, it does make sense. So then as you can see here we have each of my devices. So if we expand each of these devices, we can see we have one of my devices, the DA22DIG, which is the big Blustream one I've got sitting down here, and we have our two inputs up here and our two outputs down here. Similarly, we've got the Planet 22C here. As you can see, there's an alert here. Interestingly, this shows that the one I bought brand new in box turns out wasn't brand new. It's clearly been like a customer return or something, because if I expand it here and look at the settings on it, you can see it says it expects to be connected to a device called Desktop AV603U7. That's not one of my devices. So that's pretty interesting because I bought this brand new from a reputable retailer. I assume it's just a customer return or something. So we can just go into there and click each of these and unsubscribe, and that should get rid of that alert and allow me to use that device properly. Yeah, there we go, that's cleared that up. So now if we want to patch these devices together, we'll patch the inputs on the Blustream to the outputs on the Planet device. So we'll expand transmitters on the Blustream device, expand receivers for the Planet device, and then all we need to do is patch channels together is at the intersection between channel 1 on the Blustream and left 1 on the ESI. We just click and it'll just patch them together. So that's now patched together. Same for the other channel there, and give it a couple of seconds, and now they're all patched together. And then as you can see here, the Tesira works in the exact same way. So if we expand that here, we've got the kitchen TV there is patched to two of the inputs on the Tesira. The only difference with the Tesira is there's a lot more channels. So we've got all those channels there for the inputs to the Tesira, and similarly for outputs from the Tesira, we have a lot more channels, 64 in total. And it's also quite nice here that when you create the input blocks in the Tesira software, it actually takes the name of that block and seems to put it into the Dante interface here, so you can kind of manage them a bit neater. I've not got mine named nicely in the Tesira software, but those names do seem to come from the Tesira software, so I might go in and rename mine, make it a bit easier to understand in here. So yep, all that works fine. We've got the patching I set up there, and we've got the existing patching from my kitchen TV into the Tesira, and that all works. Now, of course, each of these mappings is just a single mono channel of audio, so for stereo, you just need to map two of them through together. So we'll now do a quick run through of the sort of other stuff in software here. So here we have kind of the grid that we've taken a look at before. There's also a tab for device info, so this just kind of shows info about each device, versions of software, all that kind of stuff, IP addresses, network config, everything like that, just fairly basic stuff really. Next tab here we have clock status, because all these devices have to kind of sync a clock source between each other. So as you can see here, one device in the Dante network becomes the leader, so that's, in my case here, it's the Tesira, and all the other devices use that as a reference clock. And that just kind of shows they're all in sync together. You can see here stuff about primary and secondary network interfaces. Most of the devices have not applicable because they've only got one network port. The Tesira has two network ports, so you could have a sort of redundant network connection, but I'm not using that, I've just got one connected. Network status, same idea, just shows sort of network health in general. Events, some sort of alerts, that kind of stuff, nothing too fancy there. And then in addition to that, each of these devices has its own configuration section. So if we just double click on the device here, we'll go for the ESI Planet. That pulls up an additional window that has configuration for that device. So in here we can see we have the receive channels, so that's showing the receive channels that are mapped to the Blustream device, sitting on that page there. So now on the next tab, you've got the latency. This just shows a graph and shows the sort of latency between the two devices as they're and shows how they're kind of performing. Then on the next page, you've got the device config section where you can rename the device, set the sample rate, encoding, unicast delay, all that kind of stuff. Sample rate's quite interesting because if you're patching two Dante devices together, the sample rate needs to be the same between them. When I first set these two devices up, the Blustream was set to 48K, as is my Tesira and everything else, but the ESI Planet was set to 44.1K, so I couldn't patch them together. So I just had to come in here and change the sample rate to 48K. So if you find it's not letting you patch devices together, it doesn't tell you, it just doesn't do anything when you click the two. You may need to come in here and adjust the sample rate. And then down the bottom here, we have this option for latency. And this is quite important when it comes to Dante. With Dante, you can adjust the latency of each device. Of course, a lower latency will reduce the time taken for audio to pass between the devices, but if the latency is too low and your network can't keep up, you'll experience issues. So you just need to find a sensible value that works for you. Every switch that the data needs to pass through will add a bit more latency. So if you have a bunch of switches between each of your Dante devices, you might need to increase the latency, or if you have a setup like mine where all the Dante devices are connected to the same switch, you can probably set this pretty low. Then finally, really, on the next page, you've got this network config section. As I mentioned, it does everything but automatically by default using DHCP or IP address auto configuration, but if you wanted to set static IP addresses, you can do that in here. You've also got this option up here for Dante redundancy. That doesn't show up on this device because it's only got one network port, but if you come into the Tesira, it does have two network ports. We can go to there, and it gives you the options to kind of configure the redundant network ports, and similarly, you get options to configure IP addresses separately on the two network interfaces, but you only get that on a device that has two network interfaces. So now, let's take a look at this working in practice. So what we have here for my test setup is for a music source, we have this Auralic S10 Plus media player, so that's sitting down here. That's then connected to the network over Ethernet just to give it a network connection, and then it's also connected into this Blustream DA22DIG using an optical audio connection. I originally planned to connect these two devices together using an analog connection, so I already made up a 3.5mm to Phoenix connector cable to do that connection there, and then later realised that the Auralic has an optical output, so used that instead. So the music will play from the Auralic device over this optical cable into the Blustream device. That'll then put it onto the Dante network, and then to play the music back, we have the ESI unit also connected to the network, and that is connected to this speaker. So I'll start music playing on the Auralic device, that'll play it into the Dante network, it'll come out of the Dante network again, through this ESI device, and into the speaker, and we should hear music. So now if we start some music playing, we'll just do that there, you'll notice that we currently don't hear anything. And that's because if you look up here in the Dante controller software, we have not mapped these two devices together. We have the DA22DIG just off camera up here, and we have the Planet ESI device down here, and there's none of these channels are mapped together. But if we click these to then map them together, so we'll click, we've currently got the speaker connected to the left channel on the ESI, so we'll map the left channel on the ESI to channel 1 on the Blustream, click that, and straight away we can hear music. So that's worked perfectly. As you can see on the front of the ESI device, we have a couple of LEDs representing the signal. You can maybe just about make out there that the top LED is lit because that's for the left channel, the bottom one isn't lit because that's for the right channel, which currently isn't mapped. But if I come back into the Dante controller and then also map the right channel, we won't hear any difference because I've only got one speaker connected, but if we look at these two LEDs, you'll see that both LEDs are now lighting up. So that's these two devices now working and transferring audio to each other over Dante. And then, as I mentioned before, the Dante controller software is only needed to set this up. Once the devices are set up, they'll continue to work without the controller. And just to prove that, if we close the Dante controller there, I'll even go to the level of shutting the computer down. So we'll just shut that machine down there. Computer's now going to be completely shut down. And what I'll then do is I'll restart both of the Dante devices. So we'll turn off the ESI Planet there at the wall, and I'll unplug the PoE from the Blustream device. So both these devices are now unplugged, powered down, not transferring audio. So now let's turn them back on again. So turn the ESI device on, plug the Blustream device back in, wait a few seconds for both those power up fully, and then if we start some music playing on my phone, like that, give it a few seconds for everything to connect, find itself, start working again, we should get music. There we go. Took a couple of seconds there for everything to boot up, get IP addresses, all that sort of stuff. But now, without any kind of PEC, any kind of Dante controller software, the devices are still working and routing audio to each other. And now as a final demo, I thought I'd set this up with a completely standalone network that's completely independent of the network we were using previously. So all I've done is unplug these devices from the existing network, they've remembered their existing config that we set up before, and they're now mapped together. And what I've done here is I've brought in this little unmanaged, just standalone PoE switch, and there is no connection between any of this and the rest of my network. There's no router on this network, there's no internet connection, and there's no DHCP server. But I'll go and start some music playing now, so it's ready for when we get it all up and running. So we'll start some music playing like that, and we'll plug each of these devices into the PoE switch. So plug the ESI in like that, plug the Blustream in like that, and both of the devices will now power up. So they're both being powered over PoE. We can see we are actually powering the ESI over PoE, whereas previously it was plugged into the wall. And now they're going to start up. And obviously there's no DHCP server on this network, but the devices will self-assign an IP address, and once it's started up, self-assigned IP addresses, they'll discover each other, start communicating, and the audio will pass through. So just give it a little minute for that to start up. And there we go. That's the music playing. So that's worked perfectly well. And this shows with Dante that you can easily move the devices between networks, you can set them up in one place, take them somewhere else, plug them in, and they'll just work. You don't need to use the Dante controller software every time you want to set it up. You can pair your devices and they'll just work. And it also shows you don't even need some sort of network with a DHCP server or assigning static IP addresses. You can just plug them straight into a switch and they'll generally just work. So yeah, that just works. And with the setup here, if I did want to then configure this and use the Dante controller software, all I would need to do is plug a laptop into this switch, allow the laptop to self-assign an IP address, and again, it would be able to find these devices and allow me to configure them. So now, there's one final thing I want to take a look at that I didn't really go into earlier when I took a look at the configuration here, and it's this tab labelled AES67 config. AES67 is a standard for audio over IP, and Dante devices support it, at least newer ones after a certain sort of firmware and hardware revision. With this, you can use it with other AES67 devices that aren't necessarily Dante. And this can be really interesting. Now, it's not that I've looked into in too much detail and done a huge amount of research in, but I've got a little proof of concept set up here that actually works pretty well. So for this test setup, what I've done is I've set up this laptop here running Ubuntu with the AES67 daemon software installed. That's all set up and running, and I've got VLC sitting on this playing music on a loop to that sort of virtual output device that should be sending that audio across the network using AES67. I've also then enabled AES67 on the ESI Planet 22C, and that's connected to the speaker as we had before. And with all this set up and Ubuntu working, playing the music back, all that kind of stuff, in the Dante controller software, we see this option here for daemon and a bunch of numbers, also source, that kind of stuff there. And it's blue because that's indicating it's an AES67 device, or an RTP flow. As you can see, we're not hearing anything, nothing's mapped, but just like we can do with the Dante devices, we can come down to here and we can map that AES67 flow from the laptop onto this Dante device, which will play out the speaker. So we take these two options and we should hear sound. And there we go, that's working perfectly. So I'll stop the music there so it doesn't keep playing, but that works. As you can see, it's now gone red, that's because the audio flow stopped. But this does work. Now, it's not nearly as slick as using a native Dante device. There's a lot more config, it's a little bit more fiddly, and with this setup here, I have noticed slight little audio artifacts that I've never noticed with Dante devices. Although equally, this is a very old laptop. This is not an optimal setup by any means, so you could probably get a much better experience if you set it up properly. So it's not really an equivalent to using Dante device on each end, it's not quite as nice, but if you wanted to get audio in and out of a Linux system or any other device that supports AES67, and want to use Dante devices at least on one end of that setup, it does seem to work, and it is a viable option if you can figure out the config side of things. So there you have it. That was a look at the Dante audio over IP system that I'm going to be using to send audio from various TVs around the house into my multi-room audio system. And it's a really cool technology. Works really well, really easy to set up, and it's really quite powerful with the amount of different devices you can get, different types of inputs and outputs. It has a huge range of options and gives you a lot of potential. The only downside with it is that this doesn't come cheap. At the time that I bought these devices, the DA22 Opt devices, the optical ones that I bought, were around about £180 each. The DA22 DIG was around about £250, and the ESI Planet 22C was about £199. And that was at the time that I bought these, which was around about December last year. I've been sitting on this project for quite a while. Since then, the prices seem to have gone up quite significantly. So looking at current pricing, of course it will vary between countries and times of year and things like that, But currently, it looks like the DA22 Opt is around about £230 to £240. The DA22 DIG is now closer to about £340. And the ESI Planet 22C is round about £300 for anywhere you can really find it in stock. So prices have definitely gone up considerably since I bought these, and I'm really glad I bought them when I did, because I don't think I'll be wanting to spend quite as much as these will cost now. So yeah, very expensive option, but works extremely well. So there you go. Hopefully you found this video interesting or potentially useful if you're considering either Dante or just wanted to know more about doing audio over IP. So hopefully you found that interesting. But all I say now is thank you very much for watching, and stay tuned for the final video in this series where we take a look at my whole Multiroom audio system fully up and running.